Welcome to Enjoy Learning Computer Science. Hello everyone, this is Python Revision Tour 1 Part 2 where we'll continue with the tokens, literals and also variables in Python in a crisp and clear way. So this will be a Power Pack revision series and this is Part 2 of Python Revision Tour 1. Let's dive into the topic. Numeric literals. Okay, we were discussing about literals in the previous video. This is the continuity of the previous video, numeric literals. So numeric literals, we have three types: int, float and complex. Integer means any number without decimal point, so whole numbers without decimal point, and it can be positive or negative, right? So that is your integer. Then the next one is float. Float is numbers, positive or negative numbers with decimal point. You can see here 543.378, there is a decimal point. Minus 23.001, you have a decimal point as well as a sign. So it can be a positive or negative number with decimal point, that is float. And the next one is complex. Complex will be in A plus Bj form where A and B are floats. Okay, so you can see here A 2 plus 3j. Okay, it is 2 plus 3j. 2 is also a real number. 3 is also a real number. J will be an imaginary number which is square root of minus 1. So numeric literals are of three types: integer, float and complex. The next one, integer literals. So integer literals, we have decimal integer literal, octal integer literal, hexadecimal integer literal. So decimal integer literal means sequence of numbers, combination of numbers between 0 to 9, but it should not begin with 0. That is the only condition. Decimal integer literal should not begin with the number 0. It can be positive or negative. Now octal integer literals. Octal means 8, right? So how many digits are allowed? It is only 0 to 7. So starting with 0. Octal integer literals are represented using the number 0 followed by the letter O. This O can be uppercase or lowercase. So 0, O, 26 represent an octal, valid octal integer. 0, O, 51. Now look at this one. 0, O, 281. This is invalid. Why it is invalid? Because octal numbers should be between 0 and 7. Here we have 8. Hence it is invalid. Similarly 0, O, 98. 9 and 8 are not valid numbers in octal system. Octal integer literal system. So it is not valid, right? The next one is hexadecimal integer literal. Hex means 15. So the sequence of digit 0 to 9 and 10, 11, 12, 13, 14, 15 will be represented by the letters A, B, C, D, E, F. So here it begins with the digit 0 followed by the letter capital X or small x, right? So you can see here 0x26. It is valid. 0x9c. 9 is a valid number in hexadecimal. C is also valid number. So it represents 12. C represents 12. Now in the next one you look at here 0x26G. G is not a valid digit for hexadecimal. Similarly Q is also not a valid digit. P is also not a valid digit. Hence these are invalid. So integer literals are decimal integer literal, octal integer literal and hexadecimal integer literal. Next comes the floating point literals. Floating point literals means the numbers which have fractional parts, real, also known as real literals. So this can be represented in two forms. One is fractional form and the other one is exponent form. Fractional form is the normal form. It should have at least one digit with a decimal point either before or after. So you should have a decimal point along with a number either before the decimal point or after the decimal point. You can see here 9.0. Yes, correct. Minus 51.89. Valid. minus 0.0, you have a decimal point, number before and after as well as positive. Here you can see 0.7. There is no number before the decimal point, but also it is valid because it should have at least one number before or after the decimal point. 6 point is also valid. So these are all valid. Now 8, it is invalid because there is no decimal point. Plus 14/6 is not accepted. Only decimal point can be there. So this is invalid. 21 comma is a special character which is not allowed. Here 67.008.12, there are 2 decimal points, hence this is also invalid. So this is fractional form. The next one is exponent form. So a real constant in exponent form will have 2 parts. One is mantissa, the other one is exponent. So the mantissa means if I am writing 0.14 E05, that is or you can write a number 25 into 10 to the power 5 or like whatever it is. So this power only we will writing in the exponent form. So this the numbers which comes before the letter E is known as the exponent. After the letter E will be the exponent. I'm sorry, the numbers which comes before the letter E is your mantissa, and the numbers which comes after the letter E should be your exponent. Now your mantissa can be a real number, but your exponent should be an integer. Your exponent should be an integer. Okay. Now you can see the example 121 E04. Yes, here 121 E exponent is an integer, so it is valid. 1.71 real E06, it is valid. 12.6 okay, valid. In an exponent you can have a positive or negative integer, so this is also valid. 3.E2 is valid. This is also valid. Now 1.5e, it is invalid because there is no exponent given here. Now next one E5.2. So exponent is a real number. This is not valid. Here mantissa you have a comma which is not valid. So valid and invalid floating point literals. These are the valid and invalid floating point literals. The next one, Boolean literal. What are the Boolean literals? There are only 2. True or false. Correct? So true and false are the only Boolean literal values in Python. So when you use relational operator, when you compare, your output will be neither true or false. Here A is equal to 20. B is equal to 50. Print A greater than B. Is 20 greater than B? No. So it returns false. Print A less than B. Is 20 less than B? Yes, it is true. Okay. So true and false are the Boolean literals. Now special literal, none. None literal represents the absence of a value. It does not mean it is equal to 0. No, it represents the absence of a value. The same way we use null in SQL, no? So here in Python we use null literal to represent the absence of a value. So we have a data type called none type. So I am assigning A is equal to 20, B is equal to none. So when I am printing B, what it is printing? None. So what is the data type of the variable B? It is none type. So special literal is none. The next one is literal collections. Literal collections can be list, tuple, dictionary and sets. So list, tuples, dictionary, sets we will be learning in the coming sessions in detail. So these are the literal collections. Now variables. What is a variable? So normally variables can store values, right? But in Python, variables are not storage containers. They are the names given to a memory location. For example, if I am giving A is equal to 100, I am assigning. So this value 100 will be stored in the memory location somewhere. So the variable A will point to the memory location or the memory address where the value 100 is stored. Okay. So name given to a memory location is known as variables in Python. So when we, it is not necessary to declare the data type of a variable in Python. Automatically Python will assign the data type of the value which is set in. For example, what is the data type of 100? It is integer. So what is the data type of the variable A? It is integer. You can see here I have assigned name is equal to Susan. What is the type of data type of Susan? It is a string. So this it is a string means, so what is the name data type of the variable name? It is also a string. Now x is equal to none. So what is the data type of none? According to the value which is assigned to the variable, it is none type. Now a is equal to 10. 10 is an integer. So variable a is also integer data type. Now b is equal to 134.78, which is of float data type. So variable b is also of float data type. Now s is equal to true. So true is a boolean variable. So here s data type of the variable s is also boolean. So data type of a variable will take the data type of the value which is assigned to the variable. So variable is nothing but the name given to a memory location. It is not a storage container in Python. Multiple assignment. It is possible to assign multiple values to multiple variables or a single value to multiple variables. Okay. So assigning same value to multiple variables can be done using like this. So A is equal to B is equal to C is equal to 100. So now what is A? 100. What is B? 100. C is equal to 100. So this is the way you have to assign same value to 3 different variables. It can be 4 or 5 also. Now assigning multiple values to multiple variables. Let's take 3 variables and assign 3 values. So x comma y comma z is equal to 20, 70, 100. So 3 variables, 3 values. The first value will be assigned to the first variable, second to the second variable, third value to the third variable. So this is how you have to assign multiple values to multiple variables. And swapping also can be done easily in Python. So a comma b is equal to 20 comma 100. I want to swap these 2 values. I can simply write a comma b is equal to b comma a. What is b? 100. So a will take the first value. What is a? 20. Correct? So here the value of b is 100. What is the value of a? 20. Now I just changed. Now when I print, what is the value of a now? It is 100. What is the value of b? 20. It is swapped. So swapping is very simple in Python. Dynamic typing, very important concept in Python. So dynamic typing is, I'll explain with an example. I can say a is equal to 20. What is the data type of a? Integer. So a variable is pointing to a data type of integer. Now in the next line, I'm just writing a is equal to high. Now what is the data type of high? String. So now what is the data type of a? It is string. So a variable pointing to a value of certain type. So a variable pointing to a data type of integer. Now it is made to point to a data type of string. So it is dynamic. This is only dynamic data type. You can see I'm giving a is equal to 10. Print a. So a will point to the value where 10 is stored. So a will point to the memory address where 10 is stored. Correct? Next one is, I am now giving a is equal to Python. So when I am giving this statement, when this statement is executed, a will not point to the value where 10 is stored. Instead, a will point to the value where Python is stored. So this is dynamic typing, and Python supports dynamic typing. Correct? Now static typing. Static typing means once you declare a value variable, it cannot be changed. So in C or C++, first you have to declare the variable. I am declaring int C. What happens? Throughout the program, the variable C will be of integer data type. It will not access any other data type. So it becomes static. It becomes the same constant. So data type of a variable cannot be changed. Once declared, data type is fixed. So C and C++ support static typing. The Python supports what type of typing? Static or dynamic? Obviously, it is dynamic typing. You can assign any value for variables, right? So Python supports dynamic typing. Type conversion. Converting one data type to another data type is known as type conversion. Process of converting the data of one type to another type. There are 2 types of type conversion. One is implicit, the other one is explicit. Explicit is also known as typecasting. Okay. Now, implicit means automatic conversion. No need to do the conversion by the programmer. Automatically it will be converted. So how it will get converted? Lower data type will be converted to higher data type. You can see here A is equal to 100. What is the data type? Integer. B is 10.5. What is the data type? Float. So among integer and float, which is the highest data type? Float. Now C is equal to A plus B. So your output will be converted into higher data type, which is float. So this conversion is done implicitly, automatically. We are not doing any conversion manually. So this is implicit conversion. The next one is explicit conversion or typecasting, which is done manually by the programmer by applying the function int or float or string. Look at the examples. S is equal to 100. So what is the data type? S string, because which is given within quotes. S is given within quotes. Now I want to convert this string into integer. So X is equal to, I am manually using conversion functions like int. Forcefully I am converting this string into integer, int of S. So your X will become 100. Now what is the data type? Integer. So string is converted into integer using int function. Similarly, float A is equal to 100.35. This can be converted into integer using int function. So int, float, string, all these functions are available for manual conversion. Input statement. We are all familiar with input statements. Let's have a quick revision on input statement. It takes input from the user. Input statement returns a value of string data type only. Whatever you are receiving as input, it will be of string data type. So you can see here A is equal to input, enter any number. Enter, I am giving the number is 100. What is the data type? Even though I am entering a number, it is of string only because input returns a value of string type. If I want to receive a value of integer, then I have to use explicit type conversion. A is equal to int of, input of, enter any number I am giving. So type A, what is the data type? It is integer. So input returns a value of string data type. Now what is print statement? It is used to display the output. Correct? So used to display a string. This also display a string on the console. So what is the syntax? Print within parenthesis the objects to be displayed, comma, separator. Separator is optional. You can have a separator string also, that is also optional. End is equal to, you can have, that is also optional. Let me explain with an example. A, B, C is equal to 10, 20, 30. So print A, B, C. So I didn't give a separator, I didn't give an end. By default, the separator will be a space. So all the values will be printed separated by a space. Default separator is space. Now print A, B, C, separator is equal to comma. I have given a separator. Now the values will be separated with commas. Make sure separator will not come at the end. It will not print like this 10, 20, 30, will not come. It will only separate the values. Okay. Now you can see print 1, end is equal to, print 2, end is equal to. So when the first line is executed, it will print 1. Okay. And what is end? Ampersand. And your cursor will remain here. Because end is equal to ampersand, it will not go to the next line. Next print statement 2. Again end is asterisk. So your cursor will remain here. What is the next statement? 3. There is no end statement after it comes to the next line. So if there is any other print statement, if I am giving a print statement end, so I am giving print as end. So end will be printed in the next line only because there is no end is equal to here. Okay. This is how print statement works. This is your output. Now data types. So we have what is a data type first? It specifies the type of the data where it is stored in a variable. Correct? Now data types can be immutable and mutable. What are the immutable data types? Numbers, strings, tuples. Mutable data types, lists, dictionaries, sets. Now, What is mutable? What is immutable? Mutable means values can be changed in place. List dictionary sets. Look at the example. L is equal to 246810. What is the ID of L? Memory address 658024586112. Now I want to change the index 2 into 44. So which is index? This is 0, this is 1, 2. So this 6 I want to convert into 44. Okay. So for that I am writing, what is the index of 46? It is 2. So L of 2 is equal to 44. When this statement is executed, L, I am trying to print L, what happens? Now the 6 has changed into 44. Now let's check the memory address. Is the same. This memory address and this memory address both are same. So the values are changed in the same memory location itself. This is mutable. So list is mutable, dictionaries are mutable, sets are also mutable. Now let's see what is immutable. The opposite of mutable. Values cannot be changed in the same memory location. So examples, integers, floating point numbers, booleans, strings, tuples. So look at the example. I have given a tuple t is equal to 1, 2, 3, 4, 5. T of 0. What is 0? This is index 0. I want to change this 1 into 100. So I am writing t of 0 is equal to 100. It raises an error. What error it is writing? Type error. Tuple does not support item assignment. That is, tuples are immutable. You cannot change the values in the same memory location. So integers, floating point numbers, booleans, strings and tuples are immutable. Mutable. So when it is asked differentiate mutable and immutable for 2 marks, write what is mutable, what is immutable, and what are the different mutable data types, immutable data types, and explain with an example clearly. Okay, so we are done with Python revision tour 1 part 2 also. Hope you have understood the concepts clearly. Don't forget to like, share and subscribe for more such easy and power-packed revision series. If you have any queries, please comment in the comment box. Thanks for watching. Bye-bye.